So our next unit of study is going to be sketching polar curves. So the first set of equations that we're going to go over are going to be horizontal and vertical lines. So we're going to sketch R equals secant of theta. So we've got a polar curve because this is a polar equation, and in order to graph this on a plane, the first type of graphing that we would want to do would be where we look at the input is theta and the output is R. Now, this is what we did when we graphed. We have to basically think of this as y equals secant of x, because you know how to graph that. So that's what we're doing right here. Okay, so what we want right now are different theta. So we could do this in degrees, that's fine. The input is theta, and the output is R. Now, we should know what the graph of R equals secant of theta is. We've studied it before. Don't forget, secant is just the reciprocal of cosine, right? Secant of x is the same as 1 over cosine of x. Okay, I'm going to make a larger table than usual. Usually we just go up to 2 pi or go up to 360 degrees, but this time we're just going to do a little bit more. We'll do 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees. We're going to keep going. 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, and 360 degrees. And so if we remember what the graph of secant is, we're going to end up with this curve right here. But what we really want to do is get all of those tables, the coordinates, okay, in this table of values. So we have to go through and fill in all of these values. So remember, if we are evaluating secant of 0 degrees, right, secant of 0 degrees is the same as whatever 1 over cosine of 0 degrees is. Cosine of 0 degrees is 1 over 1. The output is 1. Secant of 30 degrees is going to be 1 over cosine of 30 degrees. So I'm going to fill in all this table. Now, this is what the completed table of values will look like. Now, this is not a polar curved sketch right here, okay? This is looking at it as though you had an x and a y axis. This is not on the polar plane. What you have to do with a polar curve is plot it on a polar plane. But you need all of these points down here to help you plot, because on the polar plane, when you plot a polar point, you're plotting with an R and a theta. So you've just gathered a whole lot of points to plot. But I want you to see something, because we only picked a limited number of theta input values here. But just remember, if you look, your output here, okay, your outputs as you go up, we only got up to +2, but we could see as we got closer and closer, like if I picked like at 80 degrees, I would have had something higher than 2, okay? So my R is going to go to +infinity and my R is going to go to -infinity. So don't think we're just going to be, our largest R value here is 2. It's just because I didn't pick any other values. Like if I threw in, let's see this. So let's say a theta R, let's do 80 degrees. So what is 1 over cosine of 80 degrees? That's going to give us 5.7. And then if we went even closer, like 87 degrees, that's going to give us 19.1. Okay, so we can even hold on to those values. So now what we're going to do is we're going to plot these values on a polar plane. So the first one that we could plot is r is 1 and theta is 0 degrees. So 0 degrees means you're in standard position, radius of 1, it's going to go right there. Now, a radius of 1.15 with a theta of 30 degrees. So I would have to rotate 30 degrees, and then I would have to go a little bit more than r equals 1. So here's r equals 1. It's going to go right about there. The next one, 60 degrees, r is 2. So r is 2, 60 degrees. That puts us right here. You should start noticing something is happening right now. Those three lines are collinear. 45 degrees, r is 1.41. So I have to rotate 45 degrees, and r is 1.41. Notice what is happening here. R negative 2, 120 degrees. So remember polars, to take that point and make it so it has a positive 2, we have to add 180 to 120. That's going to give us 300 degrees. So let's plot 2, 300 degrees. So 300 degrees rotation puts us right here. 2 puts us here. Notice all of these points are forming a vertical line. That vertical line will go all the way up to positive infinity for y, all the way down to negative infinity. And that, if you put that on the rectangular coordinate plane, the xy axis, the equation r equals secant of theta is the same as x equals 1. So let's think about what would happen if I changed this to r equals 2 secant theta. So if I was to do that, change that to r equals 2 secant theta. 2 secant theta there. Okay? That means I have to multiply all of these r's by 2. So let's do that. So I took the top row, multiplied all of the outputs by 2, because it's saying take whatever you got of secant of theta and multiply what was r, multiply it by 2 first. And so we're getting, at a rotation of 0 degrees, r is 2. At 30 degrees, r is 2.3. So that's about right here. 45 degrees rotation, r is 2.8. So I have to go out almost 3 circles, right? Right there. 60 degrees, r is 4. So I got to go out 1, 2, 3, 4. You have another vertical line. Now, when r equals 2 secant theta, x equals, the equation in rectangular form would be x equals 2. So, when you just have r equals a secant theta. So let's write that down. R equals a. So when r equals a times secant of theta, we will always have a vertical line. Now, if we have r equals secant theta, we got x equals 1. When we had r equals 2 secant theta, in the first equation, a is 1. In the second equation, a is 2. And it was the vertical line, x equals 2. If I took a and I made it negative 4 secant theta, we're going to have a vertical line in which a is negative 4. So if you were to multiply all of these r values here by negative 4, the original ones, right? This was originally, right here was originally 1. This would become 4, negative 4. And if I was to graph 0 degrees, comma, -4, that would become 4, comma, 180 degrees, which would put you 1, 2, 3, 4, 180 degrees, and you would have a vertical line right there. So, if you have just, sorry, that should just be a times there, really. I put it, spaced it too far out. If you have r equals a constant times secant of theta, you're going to have a vertical line, in which the vertical line, if you wrote it as a rectangular equation, it's going to be x equals a. So now we'll look at horizontal line.